So welcome back to the lab part of the course EEE351 microelectronics devices and circuits. So I know I said I'm going to be starting right off with designing a CMOS inverter, but I just want to do just to say a little more about some things I said previously, in order to give more insight and hence give some inspiration, like for this course, for this lab part of this course. So maybe some of you may be wondering the importance of the CMOS inverter, the multiplexer, and the and the pass gates and the transmission gate and the oscillator. I would like to say they're very, very important. Check any complex digital IC or systems. You get to see this smaller component inside of those complex systems. For instance, the latest I said M2 processor for MacBook, for instance, you get to see what's inside. They basically logic gates, inverter, multiplexer, and so I think it's at this point, it makes us see the importance of little things. If any of you by chance have actually done any project relating to, say, RISC-V. RISC-V is an instruction set architecture, just like the ARM that Apple use, and let's say also the x86 for Intel processors. So you have you also have RISC-V. There's reduced instruction sets. Computer. So this one, it's unlike others, it's open source. So any of you interested in designing processors, you want to design your own processor, you can just leverage on the like the framework of the RISC-V. So if any of you have actually done something like that, you get to see that these little things are very, very important when you're building the processors, the ALU. So basically in your processor you have ALU, the control unit part of the processor. When you open those part up, all you're seeing, apart from the adders, the subtractors, or apart from that, you get to see multiplexers here and there. Multiplexer is very, very, very important. So that's why this course, the digital part of this course, is focusing on designing the CMOS inverter and the multiplexer. Yes, those are the foundations, those are the fundamental things you need to know. Then lastly, I'm just going to talk about I talked about the design flow, but in a vague way, but I would just like to talk about it in a more intentional way. I just want to check the time. Okay, just have 1 minute, so let me give you a little more perspective. So I hope you guys can see this well. So this design flow for IC design, I think this is applicable for both digital and IC. So on this part here, we start with our specifications. Then from our specification, or it could just start as idea. I think that's what this bulb symbol stands for, like an idea. Then next thing you want to do after so after thinking about the idea and you want to move to then you arrange your idea in form of specifications, valid specifications, I must say, because it's not all specifications that are realizable, I would say. So after that, circuit level schematic. So that's where the scheme comes in. So then electrical simulation, altogether they are known as schematic design, or yeah, what you do in your schematic capture interface. That's what we're going to be doing on this interface, this scheme interface. The circuit design, I don't want to do more than 5 minutes, so I will just stop it here, then continue in another video. Yeah, thank you.